Let us begin our journey into senior maths. And we'll start with the starting point, and that is methods in algebra. And I'm now going to blow your mind with that. Oh, look at that. Okay. Like terms can be added or subtracted, unlike terms cannot. It's the basis behind all algebra, really, isn't it? No examples of that. I figure we're okay. Okay, I didn't bother with any examples. But of course we need to manipulate our algebra, and that brings up the index laws, which we should be very familiar with. We know things like when we multiply, we add the powers. When we divide, we subtract the powers. When we have that parenthesis situation, that's when we multiply the powers. And then the lie that we've been telling you for a very long time, that anything to the power of 0 is equal to 1, which is of course a lie, isn't it? Because to disprove any theory, all you need is one counterexample, and then your theory's gone. What's the counterexample? Sorry, say that again?
A equals 0.
A equals 0, very good. 0 to the power of 0 is not equal to 1. What is it equal to? That's right. Try it on the calculator. It'll come up with an error. There is no answer. 0 is an incredibly weird number, by the way. Some people say it's not even a number. It has real properties unlike other numbers. You can't divide by it and things like that. Really, it's just a symbol that represents a lack of value, the absence of value. What do these indices actually mean, though? And the first time we do it, we give you a very simplistic definition of, say, oh, it's how many times you multiply the number by itself. Now, that's fantastic when we're talking about whole positive numbers. So when it's positive, everything's fine. I tend to think of a positive index to mean this. Top of the fraction. What? Well, you'll see what I mean in a sec. Top of the fraction. Put me on the top of the fraction. If it's a negative, bottom of the fraction. Put me on the bottom of the fraction. The little instructions. Or probably more correctly, it's this. Because if they're already in fractions, and if it's a positive index, it says, yeah, keep me on the same side I currently am. And if it's a negative one, you say, no, put me on the other side. Thanks, and get rid of that negative sign. Don't like that negative sign. Put me on the other side. Then we didn't have whole numbers. We said, no, let's have fractions for powers as well. So A over B. What does that mean? The top of that tells you the actual power itself. The bottom of that tells you the root. So in other words, it's the bth root of x to the power of a. You could do it that way, or some people like to do it this way and say it's the bth root of x all to the power of a. Which way is better? Well, probably the first way, if I'm talking about algebra, would be the better way of doing it. If I'm talking about an actual number, the second way. Because it's a lot easier to find the root of a smaller number. So you find the root first, then raise it to the power, then go the other way around. But when we talk about algebra, we tend to go the first way. So let's look at very, very simple examples to see what I mean. So x to the negative 3. I don't like negatives. So what's it saying? Put me on the other side of the fraction, or put me on the bottom in this case, bottom of the fraction. So we get 1 over x cubed. We've got rid of the negative, so there it is. 1 over x to the power of negative 3. That's all it means. You see a combination of things. A to the 5, b to the minus 7. Again, with that negative one, no, go to the other side. You're going to the bottom. A to the power of 5 over b to the power of 7. As we do in maths, you've probably noticed it. We just like to make things look hard. So we go, oh look, what about this? 3/4 x to the negative 4, a to the power of 9, b to the power of negative 2. Not a problem. Well, 3/4 has already been done for me. 3's on the top, 4's on the bottom. X to the negative 4, put me on the bottom. A to the power of 9, well that's a positive. You go to the top. B to the negative 2, you go to the bottom. There it is. 3a to the 9 over 4x to the 4, b squared. Okay, let's look at these fractions. X to the power of 1/4. Well, that's the 4th root of x. Top tells me the power, bottom tells me the root. 2/3, cube root of y squared. Top tells me the power, bottom tells me the root. Other way around, 3 on 2. Well, that's how a mere mortal would leave their answer. The square root of x cubed, but us super mathematicians can do better than that, because of course that can be simplified. Because x cubed would be the same as x squared times x, and the square root of x squared we know is x, so it's x root x. Bingo. But you can do that even quicker when you do something that you never do. Well, do something that you never do, because you get x to 3 on 2, with 3 on 2 is an improper fraction. So I see 3 on 2. I would never write this down, but I think 1 1/2. You don't write indices like that. It doesn't have meaning. But in my head, I'm thinking it. And why is that good? Because I can now say, oh, well, it's x root x. Because what have I got? I've got x to the power of 1 times x to the power of a half, 1 and a half. So you see an improper fraction as a power, think of it as the mixed numeral, bingo, you got it simplified straight away. Okay, so I see something like this. Oh, 27 on 4? Okay, should have picked better numbers, shouldn't I? 4's in the 27. What do we got? 8 4s are 32, no good. 8, gosh, what are 7 4s? 28, still no good, is it? 6 4s, there you go. So it must be 6 3/4, so m to the power of 6. M to the power of 3/4 would be the 4th root of m cubed. Done! Without having to worry about actually writing things down. We just thought about it and went, there's our answer. Like I say, we tend to go crazy. Let's do it. First thing I do is draw in that. What is that I just drew? What do they teach you in junior maths? What have I drawn? Yes, it is a fraction line. That's not its name though. And no one knows what that line, you've never been told what that line's called. It begins with a V, by the way. Anyone? VI? VIN? It's a vinculum. That is a vinculum. By the way, you do realise that this is where the division symbol comes from, yeah? Because division is basically fractions. And the division symbol is a vinculum with a dot on the top and the bottom, so the numerator and the denominator and the vinculum. That's your division symbol, because that's what it is. That's where it comes from. Okay, a half. Let's put everything where it should go. 1 goes on the top. Well, in algebra, we don't normally write the 1 down unless it's by itself. So 2 goes on the bottom. End of the -6. Well, that's negative. You're going on the bottom. P to the 500. You're positive. You're going on the top. Whoa! Q to the -1 on 28. You're going to be on the bottom. But 1 on 28 means you are the 28th root of Q. C to the 7 on 6 is, well, that's 1 and 1/6. You're on the top, but it's 1 and 1/6. So it's C root, the 6th root of C. R to the 69, because yin and yang, got to have that there. There it is, R to the power of 69. Isn't that great? I mean, you look at that question and people go, oh my God, but no, you just do it bit by bit and you pull it apart, there it is. We get a fraction to the -2, and this is where the negative idea is useful of thinking about it as I'm on the other side. You don't have to worry about the negatives, you just flip the fraction upside down and make a positive, put everything on the other side, and 3 squared's 9 and 2 squared's 4, you got the answer. Alright, let's solve an equation. 9 to the power of 4x plus 1 is 1 on 27. Whew, but we're lucky here because we can rewrite all of these with the same base. 27 I can rewrite as 3 to the power of something. 9 I can write as 3 to the power of something. We can change that to be 3 to the power of 8x plus 2, 3 to the power of -3. Those powers have got to be equal. -5 over 8. Gotta love indices, don't you? Okay, so our first set of questions, we've got exercise 1A, but then, see, I don't know why they wait until chapter 8 to do some of this stuff. To me, it makes more sense to look at it. So I've pulled a couple out, exercise 8A and 8B as well.